Good afternoon, students. So we'll do the session 2 today, that is on module 5, stiffness method of matrix analysis. So I'm going to share the screen now. So in the previous session, we had discussed what is meant by stiffness method, and we had also discussed about kinematic indeterminacy. So stiffness method is defined as force per unit displacement. Okay, so and we had also discussed what are the steps to be followed while doing the analysis of stiffness by matrix method. So in today's session we are going to discuss numerical problem. So we'll do this problem today. Analyze the continuous beam shown in the below figure by displacement method. Let us take EI as constant. So in the frame, in the beam shown in the figure, you can see that it is a continuous beam with the fixed support at A, roller support at B and roller support at C, and from span A to B you have a UDL of 60 kilonewton meter, 60 kilonewton per meter at a span of 4 meter, and there is a 100 kilonewton acting at the center at a distance of 1.5 meter from both the ends. So here in this problem we can notice that at support A, support A is what? It is a fixed support. So it will not allow any sort of displacement. Since it is a fixed support, it will prevent horizontal translation, vertical translation as well as a rotation. Next, so there is no degrees of freedom at support A. Now if I come to support B, it is a roller support. Roller support, if I neglect axial deformation if I neglect, what will happen? You have, you know that hinge roller support will prevent vertical translation. And axial deformation, as I am neglecting, so there is no horizontal deformation here. So it will prevent vertical translation. At support C also it will prevent vertical translation, but it will allow rotation. As since I am neglecting axial deformation, there is no horizontal displacement. So you have to consider only rotation at support B and rotation at support C. So there is rotation, it will allow rotation. So degree of freedom is how much? At support B you have a rotation and at support C you have a rotation. So degrees of freedom is equal to 2. What is the degree of freedom? It is 2. Where are those two degrees of freedom? That is rotation at B and rotation at C. So hence it is written the unknown displacements are theta B and theta C. Hence the coordinates selected are as shown in the below figure. So this theta B I am indicating with the by indicating the rotation is happening in the clockwise direction, and I mention it as coordinate 1. Similarly, I assume that rotation at support C is in the clockwise direction, and I mention it as coordinate 2. Okay, so now what is next we have to do? As I told you that the third step is to make the structure fully restrained where it is undergoing rotation at support B and support C. So what I'll do, I'll apply a restraint forces. So I'll apply a fixed support at B and fixed support at C. That is it will not allow any sort of translation or rotation at B and C. So this is the fully restrained structure for the given B. Okay. So next. So for the given B, you know that you have to find out the fixed end moment. So what type of for span AB it is a UDL. As we all know that from module 1 we are calculating the fixed end moment for all sort of beam. Hope you all know whenever there is a UDL, what is the formula that you are going to use? Minus WL square by 12 MFAB. If I have taken it as a clockwise, MFB I have taken it as anti-clockwise, hence it is negative. So MFAB is equal to minus MFBA, that is equal to minus 60 into 4 square divided by 12. So my MFAB, if it is positive, then MFBA it has to be negative. So when I do this calculation, what is the answer I'm going to get? Plus and minus 80 kilonewton meter. Okay. Similarly, if I take a point load at the center, fixed end moment formula is minus WL by 8 and plus WL by 8. So for MFBC, if it is minus WL by 8, then for MFCB it is plus WL by 8. So answer is minus and plus 37.5 kilonewton meter. Okay. So now what is that we are going to find out? What is the forces that we got due to this at coordinate 1 and coordinate 2. Coordinate 1 is where? At support B. Where is coordinate 2? It is at support C. So B is connected to span BA and it is connected to span BC. Now at BA, what is the fixed end moment you have got? It is minus 80. 1 minute, it is plus 80, correct. If MFAB is minus 80, MFAB, if I taken it as anti-clockwise, MFBA clockwise, it is plus 80. So you have to apply the equilibrium condition here. Equilibrium condition, that is MFBA plus MFBC is equal to 0. So we are interested to know the forces only at coordinate 1 and coordinate 2, nowhere else, because displacement is happening at coordinate 1 and coordinate 2. So at coordinate 1, there is a support B which is connected to span BA and span BC. So what is the final forces developed? What are the forces developed at support B? I have to use the equilibrium condition. What is the equilibrium condition? MFBA plus MFBC is equal to 0. What is MFBA? MFBA is 80. What is MFBC? It is minus 37.5. So 80 minus 37.5, if I do, what is the answer I am going to get? I am going to get 42.5 kilonewton meter. Okay. Now at coordinate 2, coordinate 2 is support C. So support C is connected to only span CB. So MFCB, what is MFCB? It was minus 30, sorry, it is plus 37.5, because at MFBC it was, the moment was anti-clockwise, at MFCB it is clockwise. So hence it is MFCB is equal to 37.5. Okay. So hope you understood, or else once again I'll explain here. 1 minute. Let me stop sharing. Okay. So now hope you can see here. So it was like this, right? So this was support B, A and C, right? So this B support is connected to this member as well as this member. What is the force developed at support B? That is why I have mentioned it as P1L. P1L is MFBA plus MFBC. Okay, so what is MFAB? My MFAB was minus WL square by 12. MFBA was plus WL square by 12. So if this is minus 80, MFBA has to be plus 80. Right. So MFBA has to be plus 80. So what is happening here is, so this is MFBA is 80. Okay. What is MFBC? We have got MFBC as minus 37.5. What is MFBC formula? MFBC formula is minus WL by 8. Minus WL by 8 it is. So it is, and MFCB is plus WL by 8. So answer is minus 37.5 and plus 37.5. For MFBA, answer is 80 plus 37.5. Okay. For what is happening, 80 minus 37.5 here, because MFBC is minus WL by 8, right? So it is 80 minus 37.5. Okay, so that is P1L. Similarly, P2L is at coordinate 2. It is connected to only to this member CB. Hence, it is MFCB. So that is MFCB is how much? Plus 37.5. Okay, hope you understood. Let me share the screen again. Okay. Okay, so that's why you have got 80 minus 37.5, 42.5. P2L is equal to MFCB, that is equal to 37.5. Next, you have to, after finding out the forces in the restraint structure, what is that next you have to do? You have to calculate the stiffness matrix. How do you calculate the stiffness matrix? Where the restraint structure was there. For example, here you have made the structure restrained at support B, right? So now you have to remove that restraint structure and allow the displacement. How much of amount of displacement? 1 mm or 1 centimeter, 1 meter of displacement is allowed here. So that can you, so here displacement is rotation. So 1 degree of rotation or 1 radians of rotation is allowed here. So unit displacement in coordinate direction 1. So hope you can see this. So here support A is fixed, support C is also fixed, but now support B, that restraint is vanished and you had applied a unit displacement of rotation 1 radiant of rotation. It is allowing a rotation. Let that be rotation be 1. Okay, so now what is happening here due to this rotation? For it is connected to member BA and BC, right? So what is happening there, we need to calculate. We are interested only at the point where there is a coordinate. Okay, so what is this K11? K11 is what? K11 is equal to what is the force developed at coordinate 1 due to unit displacement at coordinate 1. What is the unit force? What is the force developed at coordinate 1 due to unit displacement at coordinate 1? Okay, so that is equal to, you all know in slope deflection method we had discussed a equation, slope deflection equation. What is a slope deflection equation? MAB is equal to MFAB plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. Hope you all remember that. So that rotation part is there, no? So you know that near end it is 4EI theta by L and far end is it is 2EI theta by L. So the same concept is used here. MFAB we have already calculated. So for this, what is the rotation happening? What you have to take? 2EI by L into theta A plus 2 theta B minus 0, because it is connected to two members, that you have to write, plus 2EI by 3 into 2 theta B plus theta C minus 0. Okay, now what is it I am writing? Listen carefully. So here what you have to do, you are writing for where MFBA. MBA. Okay, so where you are writing, I am interested in coordinate 1. Coordinate 1 is connected to member BA and BC. Coordinate 1 is connected to member BA and BC. So it is like MBA plus MBC as you are writing. Okay, slope deflection equation. So if you are writing for MBA, what is that you are going to write? Formula 2EI by L. So 2EI, what is the length of BA? It is 4 meter. For B, which is the far end of in a beam BA, in a beam BA, for B far end is A, right? So you will write only theta A. Near end is where rotation is happening at support B. Hence you are going to near end. It is 2 2s. How much you are getting? 4 theta. Right, so near end 4 theta by L, far end it is 2 theta by L. So far end is A. So what you are going to write? 2 EI by L into far end is theta A, near end is 2 theta B. There is no displacement here. There is no translation here. So 3 delta by L, in place of 3 delta by L, you are going to write it as 0. Okay. Now similarly for span BC. For span BC, near end is B, far end is C. So near end you should get, when you multiply, you should get 4 theta B, and for this theta B, that's all, right? So what is that? 2 EI by L, 2 theta B, 2 theta C, right? So 2 EI by L, that is slope deflection equation I am using. 2 EI by L, L length is how much? 3 meter. 2 EI by L into 2 theta b. So this is the near end. Far end is theta c. So plus theta c. There is no translation, hence it is 0. So if I do this, you know that theta A is a fixed support, hence it is 0. Theta B, here rotation, what you are going to take? I am assuming that rotation at theta B is 1. So in place of theta B, you write 1. Whereas again theta C, it is 0 because I am assuming that it is a fixed support. So theta C is 0. In place of theta B, take it as 1. So what is that answer you are going to get? This is 0. So 2 into 2, 4 EI by L. Again it is 2 into 2 because theta B I am assuming it as 1. Right. So 4 EI by 4 plus 4 EI by 3. If I do, what is the answer I am going to get? 7 by 3 EI. So for K11, that is the force developed at coordinate 1 due to unit displacement at 1 is how much? 7 by 3 EI. Okay. Now, what is the force developed at coordinate 2 due to unit displacement at 1? What is the force developed at coordinate 2 due to unit displacement at 1? So at C you have to, coordinate 2 is where? Coordinate 2 is at support C, right? So you have to consider only at this point. So what is that I am going to do? C is connected to span CB, right? So again you have to write the slope deflection equation, 2 EI by L into 2 theta C plus, for C far end is theta B, right? So 2 theta C plus theta B minus 3 delta by L. Anyway 3 delta by L is 0 because no translation. In place of theta B, you have to write 1. Okay. Since theta B is equal to 1, anyway C is fixed support, A is fixed support. So then theta B is equal to 1. All other supports I am going to restrain it. Hence theta A is also 0, theta C is also 0. So if you put theta C is equal to 0, what is that? And theta B is equal to 1, what is that you are going to get? 4 EI by 3. Right. Sorry. 4 EI by 3 it is. I have made a mistake. It is not 2 EI. No, no, no. So there is a mistake here. It is 2 theta C plus theta B because C is the near end, B is the far end. So 2 theta C plus theta B minus 0. So what is that you need to do? You have to write it as this as theta B and this as 2 theta C. Theta C anyway it is 0. So what is the answer you are going to get? You are going to get 2 by 3 EI. Okay. Next, what is next you have to do? Unit displacement in coordinate direction 2. That is, you are going to allow the rotation at support C and you are going to restrain support B. You are going to restrain support B and anyway support A is already restrained. So you are going to allow a rotation at C. Let me assume that there is theta C is equal to 1. Therefore, theta A is equal to 0 and theta B is equal to 0. Now, what is K12? K12 is what? What is the force developed at coordinate 1 due to unit displacement at coordinate 2? Where you are going to apply the displacement? At coordinate 2, right? Coordinate 2 is where? It is at support C, right? So, K12 is equal to 2 EI by L into, which is the near end now? B is a near end and for B, one far end is A and other far end is C, right? Sorry. Yeah, 1 minute. Okay, so K12 is equal to K12. I'm not interested in BA because anyway there is no restraint here because even B is fixed, A is fixed. Where is the rotation is happening? Rotation is happening at support C, right? So this BA anyway it will not come into consideration. Only for BC span you have to consider. So where rotation is happening? Rotation is happening at theta C. So but now where I am at coordinate 1. So due to displacement at coordinate 2, what is happening? What is the force developed at coordinate 1? So 2 EI by L, 2 EI by L. Now for B, far end is C. So near end is 2 theta B plus theta C minus 0. So that is equal to, again what is happening? So answer is, since theta B is equal to 0, what is that? Theta C is equal to 1. So theta B, what in place of theta B you have to write 0 because now theta B is support B is fixed, so there is no rotation. Only theta C there is a rotation. So what is that you need to do? In place of theta B, write 0. So what is the answer? In place of theta C, write 1. So what is the answer you are going to get? 2 by 3 EI. Next, similarly, K22. What is K22? K22 is equal to what is the displacement at coordinate 2 due to what is the displacement, what is the force developed at coordinate 2 due to unit displacement at 2. What is the force developed at coordinate 2 due to unit displacement at 2? So therefore K22. So it is connected to span CB. So 2 EI by L into, for C far end is B. So you are going to write near end is C. So 2 theta C plus theta B minus 3 delta by L, anyway it is 0. So what is happening? Theta B anyway it is 0 because it is restrained. Where is rotation allowed? Only at theta C it is allowed. So in place of theta C, how much rotation we are assuming? 1. So in place of theta C, write 1. So what is the answer you are going to get? 4 by 3 EI. 4 by 3 EI. Okay. So final forces acting in the coordinate direction at 1 and 2 are 0. Do we have any moment or a couple or a unit force, any point load exactly at support B or support C? No. So the final forces acting in the coordinate direction at 1 and 2 are 0. We do not have any external forces at coordinate 1 or coordinate 2 or external couple at coordinate 1 and 2. So therefore P is final forces is that is equal to 0, 0. Okay. Hence the stiffness equation is what? We know the equation K into delta is equal to P minus PL. So hence the stiffness equation is, in place of K, whatever you have to write in column wise, K11, K21, K12, K22. Okay. So K11 we got 7 by 7 EI by 3. K21 we got 2 EI by 3. K12 2 EI by 3 and K22 4 EI by 3. K12 is always equal to K21. So into how many unknowns? 2 unknowns at coordinate 1 and coordinate 2. We do not have any external couple or a force at the coordinate 1 and 2, hence it is 0. Now at the restraint structure, what are the forces we got? It is minus 42.5 and 37.5. Right. So EI by 3 is common, take it out, and when you solve this matrix, what is the answer we are going to get? Theta B is equal to minus 11.875 by EI and theta C is equal to minus 22.188 by EI. So when you solve this, this is the answer which you are going to get. So after that, what is that you need to calculate? You need to apply the slope deflection equation. What is that slope deflection equation? MAB is equal to MFAB plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. Theta A anyway it is 0 because it is a fixed support, and theta B is, you got answer, minus 11.875 by EI. Anyway there is no translation, so 3 delta by L is equal to 0. So when you calculate this, what is the answer you are going to get? Minus 85.938 kilonewton meter. Similarly MBA is equal to MFBA plus 2 EI by L into 2 theta B plus theta A minus 3 delta by L. Theta A anyway it is 0 because it is a fixed support. Theta B value how much you got? 11.875. 2 theta B, hence it is multiplied with the 2. Translation is 0. So when you do that, you are going to get answer 68.130 kilonewton meter. Similarly calculate MBC and MCB. So MCB, since it is a roller support and it is a last support, obviously the moment has to be 0. Okay. So the same problem, whatever we had discussed, first what we have to do, you have to identify the degrees of freedom. So you can see here, support A is a fixed support, support B is a roller, support C is a roller. So fixed support, it will not allow any sort of translation or rotation, whereas support B, it will prevent the vertical translation, axial deformation. I am assuming it as, I am neglecting it. So what it will allow at support B, it will allow rotation. At support C also it will allow rotation. Right. So here what you have to do, you have to assume it as the degrees of freedom is equal to 2, that is theta B and theta C. Right, then you have to determine the final, for a restraint structure, what are the forces developed, then find out the stiffness matrix and find out the unknown displacements and find out the final moments. Okay, here from span A to B, you have a UDL of 20 kilonewton meter, 20 kilonewton per meter. You have a continuous UDL of 20 kilonewton per meter. The span length is 6 meter and I value is 2I for span AB. For span BC, it is the I value is just I and it is placed exactly at the center. Load is 80 kilonewton. So you have to do the same, you have to follow the same procedure like what we discussed now, how we have done the problem in this session. Try to do this problem. So this is the problem that is given as an assignment to for you to practice. Okay, thank you.